Hello guys and welcome to another Unreal Engine tutorial. My name is Saragan and today we are going to be looking at gravity. Now this is a new feature as of Unreal Engine 5.4, so you will need Unreal Engine 5.4 or above to implement. Now the good thing about this, and it is something I have been waiting for so long to do, is be able to change that gravity and change it by direction. There were several plugins that you could use that you could add specific gravity to make it a bit like Mario Galaxy or the likes. But they never really worked all that well, and you had to jump through an awful lot of hoops in order to get that working. This is so simple, guys. I'll be doing the blueprints and the C++ version of this, so if you want to see the C++ only version, you can skip. I'll see if I can put a chapter in there for you. But we are going to start, and we're going to use a third-person template. This will work with any of the templates and blank. It doesn't really specifically matter, but it's easier to see, and I can show you how to get around some of the issues you will find as well. So third person template, I'm going to use C++. As I said, I am going to do the blueprints version, but obviously I don't want to have to do this project again, so I'm going to create the C++ version as well. So I'm just going to call this gravity. Why not? I'm just going to include starter content for the purpose of this, and I'm going to hit create. Okay, so we have our little playground here. And if we hit play, we have, things to wander around. So, where is this magical gravity thing? So what we want to do is we do not want there. We want our third person blueprint here. And what you'll find, can I dock this, please? Thank you. What you'll find is in the event graph, you've got your character movement here, and we want to set gravity direction. There is a get gravity direction. Get gravity direction. You can also gain access to that and get the gravity Z. So they've added a few variables here, but very useful. Now, for the most part, people probably want surfaces to walk on. So I'm just going to create a basic surface here. A new blueprint class. We will just have an actor class here. And I'm just going to call this zone. Add this up here. I'm just going to add a cube. And no, thank you. I'm going to scale that down. Too far. Okay, so I have a cube, and let's actually scale that up in that direction. Now, for purposes here, just to demonstrate this, I'm just going to add a box collision. And I'm just going to bring this up and scale it up the same. So pretty much wherever you walk on this, it's going to change the gravity for you. And what I'll use is the begin on overlap and also the end overlap. So what I'm going to do here is that when you walk on it, this is then going to set something on the actor to say, look at me, I'm a new gravity zone, and then end overlap is just going to say, no, remove it. I'm done. I'm finished. You can reset my gravity. So over in the third person character template, I'm just going to add gravity actor. And we can just have this as a actor reference. I'm also going to add a Boolean variable just to say whether we're in grav zone. And in here, let's create a new custom function. Set gravity zone. Okay, and I want basically a property on here. I'm not going to set that just yet. And what we want to do is an is valid check here, because that's always worth doing. And if it is valid, then set that and set that to true. If it is not valid, I'm just going to set that to blank and set that to false. Now, we'll probably be embellishing this a touch, but effectively, once we have a gravity zone, we do want to come over to the tick event. If you're not planning on changing the gravity direction, then fair play. You probably don't need to do it on the tick event. But in the purposes that we've seen, for things like Mario Galaxy, you're on a sphere. You're running around on a sphere. You are constantly changing the direction because you're going over a hill. Your gravity direction isn't always going to be down. You want that pointing to the center of the sphere. So for the most part, I tend to do this on the event tick. As I said, if you're only doing it once and you've only got like a platform, you can probably just get away with setting it once. But just for completeness, I will show you how to do it on the tick, and then you can make up your own mind how you want to do it from there. So we create a branch, tag this in. If it is set to true, we want to, I'm going to do another is valid check here, just in case. Again, this is up to you whether you want to believe you've coded everything correctly and you have this set to true, but this not set might cause some issues. Then we want to get our character movement, and we want to set, that one. Set gravity direction. Now, this takes a vector. So what is the best way to deal with this? Personally, I have found for planes and boxes and things like this, actually an arrow is really good, because you can point that arrow down in the direction you want that gravity to go, and then all you need to do is just get the forward vector of this gravity, this arrow here, and then that is sorted. So how do we get that arrow, and how do we make sure that everything that we assign a gravity zone to has an arrow or a vector to call? Personally, I would use an interface, and that is here. I don't usually do the Blueprint version, so I usually do the C++ version, so apologies if it took a little time to find that. Interface, let's just call it interface gravity. And on here, we're going to have a new function, get grav direction. This is going to return a vector, and I'm just going to call it direction there. I am going to put an input of actor. You could probably tie this to the Blueprint third person, but I want to make this as generic as possible and leave it up to the actual component, the actual Blueprint to work out what this is, whether it is an actor or a player. It's probably object is probably a better word than in my case here. You might want to offset the gravity to an additional object or objects. If you do that, then you're going to need that reference to compare it to make a unit direction or whatever you want. I'm not going to use that in this one, but I just put the option there, and it just gives me that flexibility to be able to use it. So here we can call object does implement interface, and we can call that gravity. There we are. Now I'm actually going to copy that, and I'm actually going to put it down in here. So if we are valid, check that it is something that we can set a gravity to. If it's true, set that. If it's false, go down that line. And that just means that any actor that is set here is always going to be one that implements that interface, which means that we don't have to constantly do that in that tick event. So we can now do get gravity direction. This is now a message call because it's an interface. And we're going to set the gravity direction there. Now, the other thing we need to set this back to whatever the default gravity was. Now, usually that's going to be 0, 0, but if you have an obscure thing or you're in a save file or you're loading into one that you've already set, we want to have a default gravity direction. This is going to be a vector, and what we can do is grab our movement component and just get gravity direction. There we are. And that just allows us to set a default. We don't, as I said, generally need to do that, but it's always wise. And then we can just have, if it is not valid, we actually don't even need to do that in here. It's fine. We can do that down here. If it's not valid, then we want to set this to our default. So we will always be default as soon as we leave the zone. You can change that how you want. You might want to leave it in that state. So you may want to make this sort of an optional. So if you're doing a game where you change gravity to sort out puzzles or something along those lines, then yeah, you could probably take that out and leave that. So what have we got here? We've got our event tick. We are checking whether we're in a gravity zone, whether our object is valid. We're getting that gravity thing. I'm going to set that to self in this instance. As I said, I'm not really using this, but I'm setting it anyway, and then we get that gravity direction. Now, the only things that we need to do here is actually add the interface. So come over to class settings, add your interface down here, search for your gravity, and you'll get this get gravity direction, which here we can then grab our arrow and get forward vector. Now that allows us to just work from that. So does this work? Does it work straight out the box? Well, let's find out, shall we? No, it won't, because we haven't actually called anything here, which is fine. So this is going to be cast to BP third person character. I'm also going to set that down here. And here we're going to set gravity zone. And then this gravity actor is just self. Relatively simple. You could probably put this into a blueprint function library or something if you're really that bothered. But in this one, I'm also going to set this to null. And that means that when they leave, they're going to set it to null. The only issue with doing this is that if you have two gravity zones, we need this to check the we're not setting it to null when it's already changed. So over into your BP third person thing, just make your gravity actor public, and just do get gravity actor. Put a branch in here, and we just want to do equals and put the reference to self. And that just means that, when we leave the box, if the gravity actor is still this one, then we can set it to null. If it isn't, it's already changed. We don't really want to mess with that. Because otherwise you'll be messing with the next gravity zone. Is that everything? I think that's everything. Let's grab this in here. Put this just slightly off the box. And we got gravity! Sorry, yes, of course, we need to actually do something with that. So why don't we rotate that? I'm just going to actually scale that a little bit. Oh, that's a big gravity zone. Maybe I scaled that a little too much. Yeah, that's fine. Let's see what happens, shall we? Nothing. Why does nothing happen? Okay, so after a little bit of investigation, I made a mistake as expected. We don't want to check the gravity actor implements this interface because we haven't actually set the gravity actor. We actually want to get the gravity actor from that we're passing in, whether that implements the interface. So that, in theory, now gives us a gravity zone, and we are now horizontal. Nap time. Now, so what is the issue with this now? I'm hitting up, and you can see it's trying to sort of go into the floor. It doesn't really know what to do. The left and right is still fine, but yeah, this is down to the blueprint template. Now, because I've done this in C++ as a C++ project, I would actually have to change it in C++. But the easiest way to fix this would be, instead of using the forward vector of the actor, use the forward vector of the camera. It means if you're still looking at the floor, you will move very slowly, but it is a way of getting around this. Effectively, it's just the way that the third-person template's been set up that is causing this, rather than, So that is effectively how Blueprints works, and this is fine. We can add another gravity zone. Let's add one. Where's the thing? I can scale this down a little bit. That was a little excessive. I apologize. And let's duplicate you. Rotate you. And I'm just going to stick you there. So in here, we have that one, and now we have that one. So the transition's a little obscure, but it works. It works. So that is pretty much the blueprint aspect, or at least what I recommend for the blueprint aspect. I will go over how to change the controls in the C++ version, because I actually have the code here for this, for the character. But go away. Obviously, in the blueprint version of this template, you'll be looking for your move function. And as I said, you just need to get your camera and then change these two to be the camera's forward vector and right vector. That will solve pretty much most of the issues. The other issue you'll have, which, as I said, I will demonstrate in the C++ version, is the animation for walking only really works on the X and Y axis. It doesn't work on the Z, so you will have to change the animation to also allow for a Z axis. So when you're running, it allows it caters for the direction that you're currently facing, rather than just the X and the Y. But that is the Blueprint version. Why don't we move on to the C++ version? Now, this is pretty much going to be exactly the same. We are going to have a Unreal interface, which we're going to call CIF Gravity. Okay, that's finished compiling. Reload all. We now have our interface, and we want a U function blueprint implementable event. Do I need anything else? No. We'll just have get grav I mean, feel free to ding me that. Blueprint callable as well. A actor. Just call it actor for the moment. No, we want f vector here. So we want to return that f vector. So that's pretty much it for our interface. Control f build fail y private function. Oh, don't forget to put it in the public. Why have I put it up there? Idiot. In there. There we go. I get there in the end. Why is it complaining? Okay, well, I don't know exactly why it was complaining at that, but either way, I have just put callable, implementable, and I'm just giving it a category of gravity. That seems to now compile. So let's go to our zone. We already have this get gravity one. I'm just going to copy that for the moment. And we can add our CIF gravity, which gets our get grav direction, grav here, and that's effectively the same thing. You can either do that here, or if you have created a let's get rid of you. That was my debugging template. Or you can, attach it to a object in here and do exactly the same thing. It doesn't really make much difference. You can just implement this anywhere. That's the whole point of C++ in this instance, is that you can attach this to a C++ class, or you can attach it to a Blueprint class. As long as you make it available for implementation, you'll be fine. I'm just putting it in there just to show that this bit works from here. I am also going to disconnect you, and get rid of you. Most of that logic is going to be the same, which is fine. But in here, in our C++ side of things, we can now come to our character. And we are going to create a new function. I am going to function blueprint callable. And this is going to be void set gravity actor. Actually, I just call it grav actor, just so it doesn't conflict with the other ones. And we want an A actor pointer to an actor, which is fine. I also want a U property. Read write. Category, I should call it gravity. Edit anywhere, and this is going to be an A actor grav actor, and then I get rid of that. Another one for bool has grav. So as you can see, it's sort of very similar to the blueprint ones if you paid attention to the blueprint ones. If not, then this is all new. Good job. So we have this. We need to implement that. So we need to set our gravity. Why have I got an L there? And we have our gravity. So if actor and if what was it? It was actor class implements. There we are. Gravity static class. We do need to implement this. Oh, UCIF. Is that going to validate? Nope. Now it'll validate. There we are. So if we implement, have this interface implemented, we want to, what do we call our variable? Grav actor, actor, and then has grav, it's true. And then if not, put a return here. That equals null pointer, and then this equals false. I find the C++ a little bit cleaner to do, but now we need the tick event. Okay, public. Put that in there, and in here, I'm just going to stick it here. Get rid of the virtual because we do not need that. What? Okay, and we need to call the super tick delta seconds. Right, so we now have our tick event, and we can do grav actor if grav actor is set. Then we want to do get character movement, set gravity direction, and in here we want to do grav actor get grav. Let's change this slightly, and we have CIF gravity, the UCIF gravity, keep forgetting that. I'm just going to call it G just to make it a little easier, and we want to cast to that with our grav actor. Now we can do in here G get grav. What did I call it? Get grav de. And we can do this. Why are you complaining? Okay, I forgot that this was actually the I part of the gravity. There's two, there's the U, and then there's the I, and yeah, so I forgot about the fact that I need to do the I version. And this is also not going to work because we need a cast U object and G. Because this takes in the object that we're calling it on, and then obviously the actor that we our setting. One thing we didn't do is add another one. Default grav, and that is an F vector. Take this, and in our constructor here, we set default to our get character movement, get gravity direction. So if grav actor, do that, else we don't need to worry about that because it is in here. We need to add that on the bottom of there. Let's move that down there just in case the tick event happens in between things. So is that everything? So we have our default gravity here. We have our actors. If it is implementing that, we are setting that and has gravity. Otherwise, don't, and go back to the default. And in the tick event, we have, if we have a gravity actor, cast it to our interface and call the get grav direction for that. Now, I think that should be everything. Cool. Now in here, we are, what do we call that function? Again, I've already set grav actor. Set grav actor. And this is going to be self. And then we've got the same here. To nothingness. Right, so we're now calling the set grav actor that's in the C++ version. Again, if you're doing the overlap, you can actually just do that in the C++ version, but I've only got a blueprint version of this overlap control, so we don't need this tick event anymore because that is handled in the C++. This now is no longer handled. Just checking to make sure I've got everything correct. I think I've got everything correct. And our zone is now implementing the get grav. I'm going to go to the class settings and remove the original. And then just delete that function. So this is now just running off our C++ interface. So in theory, we die. We die horribly. Why have we died horribly? Okay, cheers now. We'll do it the other way then. That's fine. Execute. Grav. Directory. Direction. And then this. Let's do it that way. Review. Let's get that into one line. Lovely. Let's try that, shall we? Lovely. There we are. C++ version for you. As you can see, we've still got this walking problem. So why don't we go ahead and resolve that as well? So as far as the character movement goes, here we have our move. And as I said earlier in the video, we need to just get our camera, get follow camera, get forward vector. That is going to be that. Copy that. And we need get right vector. So with that, compile, run that. This should now at least allow us to go up. But as you can see, the animation is not taking into account the Z direction. So it does work, and obviously if you're looking straight down, you're moving very slowly. So, I mean, let me know down in the comments if you find a way of fixing that. I would be more than happy to sort of alter or create another video on it. But you can see everything is sort of working. However, this happened. It basically means that we were outside, and yeah, we didn't like leave it. So there are a couple of things that you probably want to look at in terms of bugs. That is pretty much going to be on the zone here. Where did I actually put the... So something in here didn't work. The end overlap didn't work here for some unknown reason. So yeah, best to do a bit of debugging on that. But for the most part, that is sort of how you implement that in C++. I don't even know why I clicked build there. No, thank you. Really, I just wanted to show how you would sort of implement this gravity direction. And that, as I said, works as, you know, we have maybe a sphere. If I add another blueprint class, actor, BP sphere, let's add a sphere here, add a sphere collision, and the sphere collision needs to be bigger. This can then implement our CIF gravity. This has to get gravity direction. We can now let's cast to BP third person character in here, and we want to get actor location. Then we want unit vector. Get unit vector. There we are. Add that into here. And on here, we want our begin overlap and end overlap. We can pretty much just copy that logic in here. And drag you into the world. Maybe scale you up a little bit. And now, you know, we can run around a sphere. So you can implement things fairly easy in Unreal Engine, and that is pretty much how the new gravity stuff works in the blueprints and the C++ side of things. They're pretty much identical, guys, so you know you can't really go wrong, but that means you can now replicate that across to servers and have multiplayers and have ships flying around where the gravity is all pointing towards the ship. It is a game changer, guys. I've been waiting for this a very long time, so I thought I'd do a video on it specifically because of that. But thank you very much for joining, and I will see you in the next dev video. Bye bye.